Hello, and thank you for listening to this episode of the Night Sky Podcast, episode 2, recorded on December 14th, 2015. Today, I'm here with Marina Hansen, who is going to talk with me a little bit more about the ongoing Kickstarter project that we have going, and talk a little bit about some of the night sky stuff that's happening around us right now. How you doing this evening, Marina?
Hey, Billy. I'm doing pretty well. How are you?
I'm doing good, and thank you for coming over and hanging out at the studio and recording some stuff with me this evening.
I'm happy to.
Should be pretty fun. We've been kind of working on a few studio things and trying to get some stuff sorted out for the podcast and trying to do some ongoing stuff. And I think it'll be fun for you and I to do some of like the post-production work. I think that'd be cool to start doing as a project with this, kind of like what we had been talking about figuring out what to say and record spots for like pre-recorded segments, get the audio beds.
Yeah.
And get a structure set up about how the podcast is going to come together when we start doing it more frequently.
Yeah, I think putting together those little pieces are going to be good.
Yeah, it'll be a lot of fun to do that. But yeah, you should start thinking about the stuff that you want it to do or how it should be. But I'll try and start writing some stuff up too. And then what I'd like to do is put in like find some cool like taiko music beds that are sort of nondescript. Or like some cool like audio cues, that sort of thing that we can get. Some cool like intro and outro stuff that we can find. I think there's a lot of stock stuff that's available to us too that we should try and put in, like stock music stuff that we can pick out one for the intro and the outro, so that when we post produce it, we can put together the pieces and have it sound like a full production.
We should look at that. I've never really looked at like stock music before.
Oh yeah.
Yeah, I've looked at stock photography and a little bit of stock video stuff, but not music clips.
A lot of the stuff that my dad was doing had to do with like the stock music stuff, and so I was thinking about just kind of cruising through there for a few of the podcasts that we want to put together, and we could find a couple beats or music beds that we can work and pull something out of, and that's what I did like for way back when I put one together. Is you just put together a couple loops to kind of put your own music together, and then you can use that. And
did you do that for KBVR?
Yeah, that's what I did for the old podcast that I was doing. So this one for Night Sky stuff, it'll be a lot of fun. Guys, I want to try and like do this one as a more tightly produced podcast over time, or like something where there's like a couple specific beats to hit, which would be a lot of fun to do. It'll be cool to try and see this thing grow over time. But this project, I think specifically the nightsky.io website and the calendar and the podcast is all going to take a lot of nurturing this year. Mm-hmm. Like a lot of energy and a lot of like feeding it to try and get it to be up and running and to be working. And it should be good. It's a cool project. I like the night sky stuff that we're going to get to do. And it's a good excuse to kind of write off all of the like photographic equipment that we want to do for night sky photography and all of the trips and travel stuff that we'd want to do, or telescopes. All that stuff is now included in what we can kind of umbrella as all the stuff that we're trying to do for night sky, which will be pretty fun.
I'm looking forward to getting that telescope or a telescope.
I'm looking forward to getting a telescope too. In fact, that's one of the things that I'd like to do most is get whatever it is that's the DSLR hookup kit for a telescope.
Yes.
And that's why I want to try and start doing some more like deep sky astrophotography. In fact, the project that I'm looking at the most is like photographing Jupiter day over day over day, and then you can see the changes in the placement or the orbit of the 4 moons that we can see around it with just a regular telescope.
That would be really interesting to get some photos of.
Yeah, it'd be really cool. I'd like to photograph the planets as they go by. Like this summer, I want to be ready to do some of that stuff, I guess, to kind of show as like content on Night Sky that we're making right now, and then to just have like cool pictures of Jupiter, and then I want to kind of track the orbits of, it's like the 4 moons that we can see. The 4 moons that Galileo saw when he first built the telescope were Ganymede, Enceladus, Io, and Europa. And so those are the 4 that we can see when we look into a telescope at night. And they're really big moons. They're about the size of Earth's moon, but since Jupiter's so much larger, they look pretty tiny as they kind of orbit around Jupiter. But you can still see them pretty distinctly through just a pretty regular telescope. You can see the 4 little star dots that are outside of Jupiter. But it's cool because if you watch them night over night, when you think about a moon's year is how long it takes to revolve around the planet instead of the sun. And so a moon year is really just like a couple days. Like for us, it's 1 month. That's how long it takes to go around the Earth. Or no, that's how long it takes to rotate, right? So a year is like a day. I think that makes sense for us. But to talk about Jupiter's moons, like you can see them move in their orbit over like the course of 72 hours. So in 72 hours, they'll be on the other side of the planet. So it's cool. You can like track and watch the motion of the moons as they move across or around Jupiter. And it'll be really good to do that in, I think, like April, May, and June this year. I think it'll be a good viewing period for that.
That'll be really cool to watch. I'm looking forward to getting a telescope to view it more clearly and to get some photos. I think that's going to be a really cool project.
Yeah, I think trying to sort out the photographs that we're going to make of the night sky stuff coming up in 2016 will be pretty cool. And then I guess talking about Jupiter, that's where we could talk about the viewing of Jupiter that we can have right now. And so Jupiter is going to be up primarily, I think for a lot of people, it's going to be easily viewable, easily observable during the spring months this year. I think currently the Jupiter is in Leo. And so we're going to have a lot of good viewing of that late at night, and then quite a bit more as like February, March, and April come around. We're going to see it in the night sky more predominantly. So I think right now Jupiter's in Leo, and Leo rises around 3 a.m. or 2 a.m. or so, around 2 a.m. right now in December. And so it'll be around 10 o'clock or 9 o'clock by the time March comes around. Or maybe a little bit earlier. But yeah, I think right around then. Or at least by March, we're definitely going to be able to see Jupiter in the late evening sky, or early evening, late evening sky, which would be cool.
That would be cool.
And so right now it's cool. Things you could go out and see right now if you're interested in going out. You could get up at like 3 a.m. and you could go out and look to like the southeast sky, and you'd be able to see Jupiter that's up in Leo, and then you'd be able to see Mars, which is at a magnitude 1.63 right now. And this is cool. And what we're going to be able to track over the next 6 months is Mars move from a magnitude 1.63 to a negative 2.03. And that's that big swing that we were talking about as we get a lot closer to Mars, as we physically gain a lot of space or a lot of the distance that we have between Earth and Mars. We're going to physically change that. And so we're going to be more at opposition to Mars, where we're going to be facing the full lit side of Mars that's lit by the sun. So it's going to be a lot brighter for us. Well, actually, Mars is in opposition to us all the time. So is Jupiter. I think a lot of the time that's how we see it. But sometimes you can see the planets as a crescent. So they'll be observably more visibly bright to us when like the whole lit side, the whole half of the sphere that's lit by the sun is facing toward the Earth. And since the Earth is so much closer to it, it's going to gain in brightness or in visibility at night. And that's what is going to make its magnitude jump to -2 over the next 6 months. I think it reaches its peak or its opposition point for us, I think sometime in late May or early June.
And what is Mars's magnitude right now, if we're looking at it tonight?
Yeah, I think that's where it'd be 1.63. So
and then it's going to be moving to -2.
-2, yeah, which is quite a big swing. So that's talking about like the first magnitude star system. So there's first magnitude stars, second magnitude stars are dimmer, third magnitude stars are dimmer than that. Fourth magnitude stars are almost hard to see, or like the faintest stars that we normally see. And then if you got real dark skies, you can see fifth and maybe a sixth magnitude. But that's about the limit of the human eye and the darkness or the visibility that we're able to get in the Earth's atmosphere for most of the time. And so first magnitude is what most of the stars that we see out are. Planets often jump that first magnitude rating since they're the brightest object in the sky. So that's where we're going to see Mars go from 1.6. Since it's variable, we're going to get a lot closer to it. It's going to be larger in the sky since we're closer to it, and it's going to be brighter, so it's going to swing to that -2. Jupiter is going to, I think right now is at -2, is going to remain at -2 through the spring. And
okay.
then like the moon, like a full moon is like -27 or something like that. It's like it's some really high number. And then the sun is like some whole number too. But it's just this kind of magnitude rating scale of how bright things are in the sky. And I think originally it was just kind of thought that the brightest regular star was going to be like a 0. And then everything was going to kind of drop out from that. Zeros are the brightest stars. And then there's first magnitude and second magnitude. And they kind of spread out through sort of an arbitrary or I guess it's an objective rating system. They just count like the brightest star in the sky as whatever it is, and then they kind of sort the scale from the objects around that at that point. But yeah, that's what's going to be visible. So tonight we'll be able to see Jupiter at a -2 magnitude, and then we'd also be able to see Mars. And Mars is going to be in the constellation Virgo, so it's going to be near the star Spica. And that, I think, would be rising at around 2:30, 2:45 in the morning right now. So you'd see you'd have pretty good visibility of something like that at around 3 a.m. or later. 3 a.m. to sunrise, you'd have pretty good visibility. And then the other cool thing that's up right now, and maybe only for a couple more days, is Comet Catalina. So in that same line, there's like Jupiter in Leo, and then there's Mars in Virgo, and then there's Comet Catalina that's just a little bit past that, or closer down toward the eastern horizon, toward the sunrise. But that's a magnitude 4.6 right now, which is going to be pretty dim or pretty difficult for the human eye to see, but you could probably see it. It's just going to be a little bit more wispy of a shape when you look at it or when you try and observe it. It won't be really predominant or really visible, but it's going to be this kind of wispy look, or this kind of like a star that just got a little smudged out is what it sort of looks like in the sky. But it's difficult to observe because all the comets, since they're kind of swinging around the sun, a lot of the comets are always up right around daybreak. And so it's really hard, and there's really quite a few more comets that pass by us in the daytime that we're never able to see because we don't have a good ability to observe them, since they're inside the sun from us, or they're in the place where we would see daylight, right? Like it would be looking at the half of the world that's facing in toward the sun, and that's what the physical location of the comet. So we're just never able to identify, or we're never able to observe like the comets that are there. I think until very recently, until like some of the new more modern technology, where we've been able to identify asteroids or comets that were inside the sun. But the cool thing is that like right at the morning or right at sunset is when you're able to observe a lot of these comets before they set like below the horizon. So for Comet Catalina, I think you only have maybe an hour or so after Catalina has risen before the sun rises. And so that's where you're starting to deal with a lot of twilight, or a lot of light in that section of the sky. And that's what makes it really difficult to view F4.6 magnitude comets, because even in a dark sky, like we were talking about a second ago, even in a really dark sky, if you live in a city or if there's light pollution, that 4.6 is going to be pretty difficult to see, even on a dark night. But then if you account for the sunrise happening and so much light being kind of proliferated into the eastern sky as the sun starts to come up, seeing a 4.6 magnitude object in the sky is going to be really difficult. But a lot of folks have done it. You can look at starandtelescope.com. And there's been a lot of like amateur astronomy photographs of Comet Catalina, and I think a few photographs from a few years past when it must have passed by. But there's a lot of information about like a 2012 pass of Comet Catalina, and it looks like it has kind of a green color to it, which I think is copper. Nah, it's probably wrong. I heard that that's what it used to be. If it was ionizing the gas, you would see green gas. And if it was like oxygen, you would see red gas. Or blue gas. I kind of forget now. I think red gas is hydrogen and blue gas ionized is oxygen. But there's like sort of these little tricks. That's how I remember it. Yeah, there's these little like tricks, or I don't even know if it's a trick, but there's just a certain spectrum of life that's put out by an ionizing gas, and it depends on what type of gas it is and what kind of visible color that we see from it, which I think is kind of interesting. But when they're looking at deep space objects, they can look at the ionized gas and then identify what the material makeup is of it based on the type of color that's being ionized off that celestial body. It's kind of cool. So you look at like a nebula, or you look at a shooting star, or you look at a few other things, and you can kind of identify its material makeup, which is cool.
That is cool. I guess I don't really know. I had thought that copper was green.
That's what I hear as it burns up in the atmosphere for an asteroid.
Yeah,
I'm not
but it'd
sure
be different for
like
a comet.
When photographing a comet, because like we talked about before, there's two tails. And
that's
so,
right.
There's like the physical tail of debris that's being left behind, and there's a lot of great comets over the last century, like stuff before we were born, of these really cool comets that are passing over the sky, and you see these really intense physical tails, all the dust and debris, all the snow and or the ice that would be like breaking off of the comet as it passes out and goes by the sun, and then it outgasses all this extra material as it starts to heat up, or as its surface heats up, since it's coming into a close pass by the sun and then going back out. But the other tail that we see is going to be like the solar wind tail, or this field of ionized gas that blows away from the direction of the sun. And so that's why you'll often see comets with two tails. So one of them is going to be sort of it could be an orange color, or it could be just like a physical color, like a gray color or white color that looks kind of like a mist. And then there's going to be another tail that's blue. And the blue tail often, or as I'd seen before, was like the ionized tail, the second tail coming off the comet. That was like the ionized gas that was pushed out from the sun. So the sun's energy kind of pushes out to the comet. And then think of like looking at your shadow near sunset on like a summer day where it's really long. You can see it way down the road. It's kind of that same idea if you were thinking about this tail created by solar wind, is that when the sun hits it, it's sort of that place where the shadow is, and it kind of blows out this big area of solar wind like past the comet. And I think that's what we see as ionized gas and sort of a blue-colored second tail. It's cool. But so you might be able to still see that for just a couple more days. I think Catalina is going to be sort of sunsetting as it moves in quite a bit closer to the sun over this next week. And then I think we're going to not be able to observe it anymore. It's going to be on the other side of the sun. So it's going to make its big swing around the sun. And once it does that, it's going to be in the sun. So it won't be observable. And then it'll be up during the day. And then kind of heading back out on its other side of the solar system. So our close pass to it will be, I don't know, however many more years out in the future until we see it next. But yeah, it's cool.
That is cool.
Little comet in the morning sky. So that's where the big business is right now for sky watching, is the morning sky. You're going to have Jupiter up in the morning. You're going to have Mars up in the morning. And then you're also going to see Venus too. I think if you stay up late enough, like near the sunrise, you're going to be able to see Venus. Which is really cool. So I think if you're trying to identify Catalina, it'll be up in the sky from Venus, but I think it would be sort of the third end of a triangle if you were to try and draw a spot between, I think it'd be like Arcturus and Spica, and then there's going to be sort of a point in between there where Catalina is out in the sky, and that'll be in the eastern sky near dawn, I think is when you'd be able to see that. But you probably find great information out at like skyandtelescope.com or space.com. One of those sources. Everything they're covering right now is all about comet news this week. So I don't know, it'd be kind of cool. I'm excited to try and do some observations of that, and I don't know, get to see some planets too. It'd be a lot of fun.
Yeah, we need to find some clear skies.
We need to find some clear skies. And speaking of clear skies, we're trying to find and trying to build for ourselves. We're working on a Kickstarter campaign right now. You can go to nightsky.io to get a link over to our Kickstarter project. We've got this nightsky.io calendar, the Night Sky calendar for 2016. And we're really excited to be putting it together. That's like a lot of the work that we've been doing this week, is trying to put together the art for this calendar, and then also start to work on the InDesign document that's going to be the template for the calendars. We put it together, which is going to be full of specific facts and calendar dates to kind of remind people of different meteor showers that are going to be happening, or different like a opportunity of a solar eclipse, or the definite option of the lunar eclipse that's going to be happening in March. We're going to be tracking a lot of the dates that are the planets moving in and out of constellations or being specifically visible at night. And I think that's going to be really cool. I'm excited to kind of draw on all the specific, interesting little details that we see in the night sky. But it's a 12 by 12 inch printed and illustrated calendar of the night sky. So it's demonstrating like kind of the specific things that we're going to see, the constellations that are going to be up for that time or that time of year and for that month. So in June of 2016, there's going to be Saturn and Mars, both in Scorpio, and Mars is going to stop its retrograde movement across the southern sky, and then it's going to start moving toward the western horizon again. And so we might try and identify that as some cool type of observation that we can make, or that we can all look at. It's kind of identifying that and tracking Mars across the sky. We can kind of note that in the calendar as we go. But there's a lot of fun ideas that we're going to have like that are going to be trying to put together in the night sky calendar.
Yeah, I think Mars is going to be a cool one to include. I think that'll be a cool detail to watch through a few of the months.
Yeah.
And yeah, it's really cool. It'll all be, these are all observable events. These are all things that you'll be able to look up and see during that month.
Yeah. And that's one thing I want to try and be be really good at is there's a lot of calendars that are just sort of machine handled. They're kind of built by algorithm.
Yeah.
And so they talk about a lot of solar eclipses that you can only see in the Arctic Circle, or things that just aren't really going to be visible, or things that...
Yeah, a lot of events happening during the daytime that you just can't see because it's the daytime.
Like the moon, I don't know, what is it, like a conjunction of the moon and Jupiter, which is like an occultation. It's where the moon kind of since it's closer to us than Jupiter, it physically passes in front of the space of Jupiter. That'd be a really cool thing to see at night. It's very rare to happen that the moon passes in front of a planet. But it's not that rare because it happens often on the ecliptic line, but it just often happens in the day or during a time where it's not going to be visible to people in the northern hemisphere at night when we'd be able to see anything like that. So it's just not really that high quality of an event to kind of see or to take note of. But there are times when it is important or when it is cool, when there will be something that's an interesting observation that we can make. Like last year in September, there's a star... I think it's Arcturus. The moon passed in front of Arcturus, which is cool. That often doesn't happen either. It's really pretty strange to see the moon interact with or cross a first magnitude star on the plane of the ecliptic. But it does happen. Like it'll happen with Arcturus. And I think, it can happen with like Antares in Scorpio. It can move through there. But the moon has like a little bit of variance in its orbit on the ecliptic line. And so it's not always exactly in the same spot. That's why we don't have an eclipse every month. You think we would. Every full moon, there should be an eclipse if the moon's in exactly the same spot, or if it's passing right on the line of the ecliptic to get hit by Earth's shadow. But it doesn't do that. It seems to have, I think it's a 6-degree variance, or it's a it's still an elliptical orbit on the moon. So the moon passes, I think it ranges about 25,000 miles further away from us and then closer to us. And it's 250,000 mile orbit from Earth. So I guess that means what? 240 to 260? I'm not sure. I think it's something like that. Like 240 miles away on the tight end, and then 250 or 260 miles away on the long end of its elliptical orbit around the Earth. And I know the words for that are apogee and perigee, but I don't remember which ones apply to which part of the arc. So I guess that's what we know so far about it, but it'll be cool. We're going to try and focus as much as we can on like specific events for sky watching in 2016. It'll be a lot of fun, and the Kickstarter project's going well for us so far, and more importantly, like the art is going well for us so far. There's a lot of cool stuff that's been coming out, and it'll be really cool to build this podcast up over the next year and to build up a lot of the I don't know, probably like a community or a mailing list or like a lot of activity around Instagram to work with kind of night sky and astrophotography stuff over the next year too.
Yeah, I'm really looking forward to that.
Yeah, it'll be really fun. So I guess we should start wrapping up. I guess there's not too much more to go over.
Yeah, I think so.
All right, cool. Well, thank you very much for listening to this episode, the second episode of the Night Sky Podcast. My name is Billy Newman, and on behalf of Marina Hansen, I say thank you for listening.
Thank you.